back to Jason's Tech Time Under 10. Today we're going to look at boiler part 2. I happen to have a boiler, which happens to be boiler number 2, that is down for inspection, and I thought it'd be appropriate to walk everybody through what we're going to look for and what's actually inside of a boiler when we get ready for the state insurance inspectors, in Ohio anyway, to come and look at our steam boilers. So why don't we look at the first thing. These are our boiler outer doors. So these doors would normally be shut, just like over in that boiler to my left and to my right. All we do is unbolt the cleats that hold these doors down, and voila. Inside of it, we have all these tubes. And this particular kind of boiler, again, is a 58 series American Standard Con-E, and this is what's called a fire tube boiler. So all these tubes don't have water in it, and there's no water inside this chamber. It's hot exhaust gas that comes from the combustion chambers right where my hand is. So that's where the natural gas comes in through the pipes, and the circuitry ignites the flame, and the flame gets in there, and all that exhaust gas goes in and out of these tubes. It makes the boiler jacket and the water jacket around this very, very hot until it turns to steam. So one of the things that we'll always replace on this is we will replace this hemp gasket. And all it is basically a hemp rope that's designed for boilers. It can get wet, it gets hot, and it does it over and over and over again. This hemp we'll use this adhesive, and we'll put it on here, and we'll shut the door around it. And this is what keeps the hot gas from coming out into our workspace. But as we look at this, I want to show you what the inspectors are going to look for. So look here, for instance. Before that inspector should come in, all this has to be cleaned off. All this. And what we use for that is a brush. And we will literally go all the way in, and if you can see inside of one of these tubes, all the way in, you can see daylight at the other side. And that's the back, which we'll show you here in a second. If we look down towards the bottom, all this dirt has to get vacuumed up. This is all just the metal and the gas and the carbon from all this fire over the course of a year since the last time this boiler was taken apart. The rust doesn't look too bad, and that boiler inspector is going to come in here. He or she is going to look at every single little tube. And if they see any dripping that looks like kind of like water dripping down the side of your aluminum siding, anything that would indicate that these tubes are compromised, they will tell us that we need to retube or weld the boiler. Because you cannot have hot water, or water in general, mix in with the fire. That's a safety issue. So as we look around, looks okay. It's a little dirty. We're going to clean it. We'll make everything look pretty. And we'll put this thing so far back into service. Over here on the door itself is what's called refractory. So refractory is basically a fireproof amalgamation or slurry of what would almost look like brick material. And that brick material is what stops the outer part of these doors from melting and warping. It keeps the heat insulated and inside the boiler where it belongs, and not melting the hot steel. You can't have direct steel. So if we look over here, we can see this refractory, and it's still in okay shape, but we can fix these cracks a little bit so it doesn't fall out while this boiler is in service. And there's some material that we can use to fix that. We look at our head pressure gauge up here, and again, it's at 0. The reason I bring this up isn't as much for safety, because we've already lockout tagged out this system, but what we're looking for is the fact that there isn't any deviation in the gauge. The gauge is actually resting at 0. A lot of times when the gauges are damaged or they need recalibrated, you'll see them, and the indicator needle will be not on 0 or up against this little metal peg right here. So I know that just at a glance, that gauge isn't doing too bad. So now we're going to walk around to the other side of the boiler, but on the way, we're going to look at other things. Our sight glass. Our sight glass is looking pretty good. Again, we need some high temperature paint. We can make the boiler look a little better, but at the end of the day, sight glass is intact. I don't see it cracked or leaking. We move on. Right here is one of our, what we call our floats for our tricock. So this part where my right hand is, that's actually the tricock. And what this is designed to do is help manage the water levels of the boiler. So when the boiler needs more water, this float and other floats in here tell the system to turn on the pumps to add more fresh water or tempered water so this boiler can continue to make steam. So the inspector's going to look at one of these brass floats right here in the tricock, and then here's the secondary. And again, we're going to have to put new gaskets on it. New gaskets over here. If you look right here, come around. We're going to have to put new gasket material onto this because it's all, every time you do this, it needs new gasket material. So we'll get that cleaned up. All right, so now we're on top of the boiler. And up here, this is where the main boiler hatch is. And this is where all the tubes of water basically go inside the boiler. So this is a good example of what does it look like inside a boiler, Jason. So again, we got some scaling. I can see and feel some steam coming back into my non-return or no return, which is right there. It's not too bad. I can smell it and feel a little bit of it on my hand from the other system. But this is basically what it looks like inside of the boiler. This is where the water is. The water is all around these tubes right now. And then this pop-off valve or high pressure pop-off valve, that valve is what's designed that if something goes wrong and this machine doesn't shut off, it will blow out all the steam to the atmosphere outside like a muffler is to a car. And that's what that pop-off valve, we need to make sure every so many years we replace it, and or if there's any leaks, we replace that. So now on the back end of the boiler, this is where the exhaust side is. This right here is the chimney or the stack. And this stack has a damper control, and all these 3 damper controls, somebody thought it was a good idea to just take that out, but that's supposed to help with the flame combustion rate and the output of the boiler. So obviously with that thing cut, that's not going to work. The other thing I want to highlight is over here, which is this gauge here, and that's our exhaust gas temperature or our stack discharge temperature. That is important for me as a boiler operator to have, because that tells me, you know, if I'm running at the right exhaust temperatures to, you know, have the best production of heat and or not have carbon buildup because it's running, you know, too rich and the temperature isn't high enough, which is going to, you know, carbon up my boilers. Over here is more gasket material that we'll have to put back on. And again, I'm looking at everything, looks okay. If you want to know how thick the steel is, it looks like this is about, I don't know, 3/8 of an inch, maybe a little bit more, maybe 1/2 inch of thick a boiler plate. So that's what this is. Looking back here, this is exactly what I was saying earlier. When you start seeing drips where it's kind of looks like something was oozing out, that's what the inspectors are going to look for. They're going to come in here and make sure that this doesn't have water that's just flowing out. So that inspector will basically say whether this is going to need retubed or not. Here's the boiler stamp. And this talks about when it was manufactured, they stamped some information. I don't know exactly what the information is for this stamp. Maybe US steel, and then the grade of steel. But if you know what that is, more than I do, please leave it in the comments on the video. I'd greatly appreciate it.